Hello and welcome to part 2 of section 6.3 on trig functions of angles. So the first thing we're going to talk about is our reciprocal identities, which were briefly mentioned in a previous video. But our reciprocal identities are exactly what they say, reciprocals of identities that we've already discussed. So cosecant is going to be the reciprocal of our sine function. So as sine is our opposite over hypotenuse when we're talking about a triangle, I'm going to go ahead and draw a right triangle. This is angle x, or theta as our previous video. This is our adjacent side, our opposite side, and our hypotenuse. So sine would be the opposite over the hypotenuse. Cosecant is the reciprocal, so that would be the hypotenuse over the opposite side. Secant is the reciprocal of your cosine function. Cosine is adjacent over hypotenuse, which means that secant is going to be your hypotenuse over your adjacent. Cotangent is going to be the reciprocal of your sine function, your tangent function, so 1 over tangent. Tangent is going to be the opposite over the adjacent side, or it is sine over cosine. So this is going to be opposite over adjacent. Cotangent then, if it's the reciprocal, would be cosine of x over sine of x. Or, talking about our triangle, it would be the adjacent side over the opposite side. So these are the 6 total trig functions that we have. We have sine, cosine, cosecant, secant, cotangent, and tangent. There are lots of other identities that are extremely important when it comes to trig functions. The first one we're going to talk about is our Pythagorean identity. And this says that if we have sine of an angle theta squared plus cosine squared of that same angle, then we're going to equal 1. So if I draw a right triangle and let one of those acute angles be theta, then sine squared of that angle plus cosine squared of that angle will equal 1. And I'm going to go ahead and walk through the proof of this. Pretending that this is in a coordinate plane, I'll let my horizontal be x, my vertical be y, and then my hypotenuse will be r. Since this is a right triangle, we can use the Pythagorean identity to write a relationship between the 3 sides. So that means that x squared plus y squared is equal to r squared. Now I know that sine of theta is equal to the opposite, which is y, over my hypotenuse, which is r. I know that cosine of theta is equal to my adjacent side, which is x, over my hypotenuse, which is r. So what I'll go ahead and do now is I'm going to solve for y and solve for x and then substitute into my Pythagorean theorem. So I'll multiply by r's on both sides. So then y is equal to r times the sine of theta, and x is equal to r times the cosine of theta. So then I can substitute. I know that x squared plus y squared is equal to r squared. That's just using your Pythagorean theorem, or a squared plus b squared equals c squared. Now bringing my trig into it, I know that my x is r cosine of theta, so r cosine of theta squared, plus my y, which is r sine of theta squared, is equal to r squared. So again, all I did is I substituted x and y for the values of x and y using my trig functions. Simplifying then, I've got r squared cosine squared theta, and that's just multiplying r cosine times r cosine, plus r squared sine squared theta is equal to r squared. From here, you might already see our next step, but that is to just divide everything by r squared, leaving me with cosine squared theta plus sine squared theta is equal to, on the right side, I've got 1. Now to write it according to the form that I have above, I would just switch the cosine and the sine. So sine squared theta plus cosine squared theta is equal to 1. And this is our Pythagorean identity. We do have a couple other forms, and the first one we can get by dividing everything through by sine squared of theta. So dividing by sine squared everywhere and then simplifying, I'll be writing things in terms of our trig identities. Sine squared divided by sine squared is 1. cosine squared over sine squared. If we go back, cosine over sine is going to be our cotangent. So cosine squared over sine squared is going to be cotangent squared of theta equals 1 over sine is cosecant. So 1 over sine squared would be cosecant squared. So another form that we have is 1 plus cotangent squared of theta is equal to cosecant squared of theta. And lastly, we can repeat that process, but divide everything by cosine squared of theta. So dividing by cosine squared, sine over cosine is tangent, so sine squared over cosine squared would be tangent squared. Cosines divide to 1, and 1 over cosine is secant, meaning that 1 over cosine squared would be secant squared. So my third form of my Pythagorean identity is tangent squared theta plus 1 is equal to secant squared of theta. Expressing one trig function in terms of the other. So I would like to express sine of x in terms of cosine of x. So I do know the relationship between sine and cosine is that sine squared of x, or theta, plus cosine squared of x is equal to 1, and this is just our Pythagorean identity. So if I want sine in terms of cosine, I'm just going to solve this equation for sine. So I've got sine squared of x is equal to 1 minus the cosine squared of x. And then to isolate my sine, I make sure and square root both sides, including the positive and negative. So then sine is equal to positive or negative square root of 1 minus the cosine squared of x. Express tangent in terms of sine where x is in quadrant 2. So this is an important thing to note because now our angle is in quadrant 2, which means that my x's are negative because we're on the left of our 0 for x. So my x values are negative, comma, and then I'm going to put my y values. We're above the x-axis, so that would be positive y values. So I might have a value, for example, like negative 1, positive 2. So this is just the signs for your x and your y values. So I know that my tangent is in this quadrant. My x is in this quadrant, which means that sine, since sine is related to our y value, is going to be positive. So I do know that tangent of angle x is equal to sine of x over cosine of x. So what we are asked to do now is write this all in terms of sine. So really, I need to find a way to rewrite cosine as sine. So I'll use my Pythagorean identity to do that. I know that sine squared of x plus cosine squared of x is equal to 1. I'm going to solve for cosine squared, so I'll subtract my sine. 1 minus the sine squared of x, and then square root cosine squared of x is equal to 1 minus sine squared, and I didn't square root, so I'll go ahead and do that now. Square rooting both sides, including my positive and negative. Cosine of x is equal to positive or negative square root of 1 minus sine squared of x. Now, since we are in that second quadrant, my x's are all negative, or my cosines are all negative, so this is going to be specifically a negative square root of 1 minus sine squared of theta. So I'll go ahead and replace that here in my formula for tangent. So tangent of x is equal to sine of x over negative square root of 1 minus sine squared of x. Tangent should be negative since it is sine over cosine. Sine is positive, cosine is negative, so here I do have a tangent value that is negative in that second quadrant. So this would be tangent in terms of your sine function. If tangent of x is equal to 2/3 and x is in quadrant 3, we're going to determine the value of cosine of x. So our first approach is to use identities. So I know using one of my Pythagorean identities that tangent squared of x plus 1 is equal to secant squared of x. I'm trying to find the value of cosine, so I can also write this as tangent squared of x plus 1 is equal to 1 over the cosine squared of x. Now I know tangent is 2/3, so tangent squared would be 2/3 squared plus 1 is equal to 1 over the cosine squared of x. So 4/9 plus, I'll go ahead and make a common denominator for 1, 9/9 is equal to 1 over the cosine squared of x. Adding, I've got 13/9 is equal to 1 over the cosine squared of x. And then to solve for cosine squared, I need to multiply both sides by cosine squared of x. And then I will also multiply both sides by 9/13, so that my equation is now cosine squared of x is equal to 9 over 13. So then to solve for cosine, I square root both sides, including my positive and negative. So cosine is equal to, square root of 9 is 3 over the square root of 13. I'll go ahead and leave as the square root of 13, and this would be positive or negative. Now we are talking about our angle in quadrant 3. So I've got quadrant 1, 2, 3, bottom left quadrant here. This is my angle x. Since we are to the left of the y-axis, cosine is negative. All of my x values on the left of that y-axis are negative, which means that my angle cosine is going to be negative. So negative 3 over square root of 13, and we won't worry about rationalizing it. Now option 2 is to use triangles. This would be my preference. So I've got an angle x in quadrant 3. And I know that the tangent is 2/3, which means that the opposite over the adjacent sides of my angle are going to be 2 over 3. So the opposite side would be 2, my adjacent side would be 3. Now the ratio divides out to be a positive value, but here we can see that if we go to the left on the x-axis, I would have a -3, and then down on my y-axis would be a -2. So that ratio of -2 to -3 is still 2/3. Now from here, I'm looking for the angle theta to find the cosine. So I'm using a reference angle to find the cosine of my angle x. Whatever the cosine is of theta will be the same as the cosine value of that whole angle x, as we talked about with our reference angles in our last video. So then what I'm looking for now is the cosine of theta, which would be the adjacent side over the hypotenuse of my triangle. So I know that's -3 over my hypotenuse. So I need to find my hypotenuse. And I'll go ahead and just use Pythagorean's theorem to do that. So a squared plus b squared is equal to my hypotenuse squared. 4 plus 9 equals h squared. 13 is equal to h squared. So h is either the positive or negative square root of 13. Since we're talking about a distance here, we're not talking about a direction on your coordinate plane. We're talking about the length of h. It is going to be just the positive square root of 13, meaning that my cosine of theta, which is also the cosine of angle x, is -3 over the square root of 13. So two different approaches. You can pick which one you prefer. I will tell you that I prefer approach 2. It's easier for me to see the values of x's and y's being positive or negative when I use that approach. And our last part for this section, section 6.3. If secant of x is 2 and x is in quadrant 4, determine the other 5 trig functions of x. Now in this case I am going to use approach number 2 using my triangles because we've got 5 trig functions to use. And if I set up my triangle once, it's pretty easy for me to go through and just find all the trig functions versus having to go through this entire process using identities 5 times. So I will sketch out my triangle in my coordinate plane. My angle x is in quadrant 4. So here is my angle x. Now secant of x is the same as secant of theta if I use reference angles. So drawing this triangle out, I can now talk about secant of theta being 2. Secant is 1 over my cosine. So that means that this is the hypotenuse over the adjacent side. So 2 over 1 is my hypotenuse over adjacent. So hypotenuse is 2, adjacent is 1, and then we can use Pythagorean's theorem to find our opposite side, which is the square root of 3. And from here we can find our remaining 5 trig functions, and we are done. Remember that your y values are negative in that fourth quadrant, so I should have a negative square root of 3. That brings us to the end. Thanks so much for watching.